Welcome back. We're in 3.6 where we're talking about quadratic functions that are in general form. This next problem, we're going to be looking at a word problem, and we're asked to find a few things underneath this. So let's take a look. A small toy rocket is launched from a 4-foot pedestal. The height, h in feet, of the rocket t seconds after taking off is given by this function. H of t equals negative 2t squared plus 7t plus 4. Now our first question asks us, how long will it take the rocket to hit the ground? So let's first of all think about what's happening here. Our leading coefficient is negative, and so that is telling us that we have an upside down parabola. We're going to have something that looks like this. And so we're trying to figure out when it will hit the ground. And so it's starting on a little pedestal right here, and then it's going over and hitting the ground here. It's not telling us what the height is explicitly, but when it says how long will it take to hit the ground, we know that we're saying, oh, we're trying to figure out when the height is 0. Let's write down something here that might be helpful. We're talking about time. Time is going to be that x-coordinate. And we said that we're calling it t on this. And then our height is our y-coordinate, but on this we're calling it h of t. So we're saying when the height is 0, find the time. So let's go ahead and put 0 in place of our h of t, which is the height that we're trying to look for. So 0 equals negative 2 t squared plus 7t plus 4. So when we're trying to figure out when will it hit the ground, we're trying to solve for t, and the easiest way to do this would be to factor this and then use the zero product property to help us figure out when it hits the ground. Well, let's look at this. Our leading coefficient is not 1, so we've got to make sure that we are being careful with the way we're getting this factored. So negative 2 times 4 is negative 8, so what multiplies to be negative 8 that adds to be that middle term, which is 7. Well, we know that 1 times 8 is 8, and we also know 2 times 4 is 8. And if we add or subtract that 1 and 8, we will be able to get to 7. So, but we need to have one of these being negative, because we're multiplying to be a negative 8. So if I add negative 1 plus 8, I would get a positive 7. So that's what we want to replace our 7t with in the middle. And we're going to go ahead and make this a 4-term polynomial so that we can do factor by grouping. Negative 2t squared. And then like I said, that 7t is going to split up into negative t, and then plus 8t, and then bring down that plus 4. Now let's split this in half to do our factor by grouping. Let's see what we can come up with here when we're trying to factor this. So out of these first two terms, it looks like we could factor out a negative t, and that would leave us with 2t plus 1, because we're doing a negative t divided by a negative t, which will give us a positive 1. Now on the second part, looks like I can divide a 4 out of both of those. And when I do that, I'm left with 2t plus 1. And this is really good that those are the same because this will help us with that factor by grouping. All right, so we're going to have 0 equals negative t plus 4. And then in my other parenthesis, I'm going to have the 2t plus 1 because that was the greatest common factor of both of those. Now let's set both of those equal to 0 and solve. On this one, I just need to add t over. That will get the t by itself, so t equals 4. And then on this other one, I need to subtract the 1 over and then divide by 2, which is going to end up being t equals negative 1/2. Well, remember, we're talking about time in seconds. Can we say that the rocket went negative 1/2 of a second? That doesn't make any sense. It's an extraneous solution that doesn't fit with this problem. So we know that t equals 4 seconds. So there is the time it's going to take to hit the ground. All right, let's look at part B. When does the rocket reach the maximum height? Again, let's look up here at this little parabola that I drew. All right, our maximum height is here at the vertex. And if I had a right side up parabola instead, then my vertex would be a minimum. So we got to keep that in mind. So to find the maximum height, I'm going to find the vertex or part of the vertex. Remember that time is what we have as our first coordinate and height is our second coordinate. So let's go ahead and solve for t, and we're going to use that vertex formula, but our variables are different, so I'm going to use t for it instead. So I've got t equals negative b over 2a. So this is the formula that we need to use to find that time. Well, the opposite of b here is negative 7 over 2 times a. So I have 2 times negative 2. Or t equals negative 7 over negative 4, or t equals 7/4. But it might be easiest, if you're going to be dealing with any kind of a graph, to change that to a decimal. And it will just make a little bit more sense with how many seconds it's going to be. So that's going to be 1.75 seconds. So that's how long it's going to take to get to its maximum height. To find the maximum height of the rocket, we know that the time it takes to get there is 1.75 seconds. So to find that height, we just need to replace t with 1.75. So h of t equals negative 2 times 1.75 squared plus 7 times 1.75 plus 4. And you can go ahead and put that into your calculator and see what you come up with here. Make sure you square that 1.75 first and then times it by negative 2. When you do that, you'll get negative 6.125. Now let's multiply these two together. 7 times 1.5 is going to give me 12.25, and then plus 4. All right, when I combine these first two together, I just get a positive 6.125, and then I need to add the 4 to it. So I get 10.125. And remember, this was in feet. Height in feet. So we need to put our label on there as it's going to go 10 feet high. Now remember, this is a toy rocket, so we don't expect it to be too high up, but that's where it will be. I hope this was helpful in figuring out the difference of when you are trying to find when it hits the ground or when you need to find the maximum height and the time it takes to reach that maximum height. Have a great day.